plus sine 2x, sin x plus from sin x plus y, cos x plus y, tan x plus y. From that sin 2x, cos 2x, tan 2x. Then the important formula is product formula. Product formula is if a sum is given, to change it into product. Sin x plus sin y, sin x minus sin y, cos x plus cos y, cos x minus cos y. Those formulas are easy to remember. Remember it as sum of sine. Sin x plus sin y means sum of sines. Sin x minus sin y means difference of sines. Then difference of sines. Sum of sines, difference of sines. For remembering those four formulas, it will be easy if you are remembering the formulas of sin x plus y and cos x plus y. That is the first two formulas you are learning. So that's easy to remember. Sin x plus y, sin x cos y plus cos x sin y. We have two terms, sin x, cos y. So the first term sin x cos y. That is the formula for product for sum of sine. That means sin x plus sin y. So sin x plus sin y will be, we start with 2. Then instead of x plus y by 2, instead of y, x minus y by 2. That is the sin x plus y. The first term is sin x cos, this is what we discussed, plus cos x sin y. This is the formula for sin x plus y. Sin x plus y. So in this formula, instead of this x and y, if we replace it with x plus y by 2 and x minus y by 2 with a 2 in front, this will give the formula for sum of sine. Sum of sine means it is the formula for sin x plus sin y. This is what we discussed. Similarly, the second term will give the formula for difference of sine. That is sin x minus sin y. Sin x minus sin y. Now, sin x minus sin y. Similarly, then cos 2x, we have three formulas, cos square minus sin square, 1 minus 2 sin square, 2 cos square minus 1. From this only, we write one important result, sin square x, 1 minus or 2 sin square x, 1 minus cos 2x. 2 sin square x is 1 minus cos 2x, 2 cos square x is 1 plus cos 2x. Those two formulas are important because it's a relation connecting an angle and half angle or multiple angle. That is x and 2x, the relation between x and its double angle. Then we learn also, you remember how to write tan 2x in terms of sine, cos and tan. Tan 2x in terms of sine, cos and tan. In terms of sine, 2 tan x by 1 plus tan square x. In terms of cos, 1 minus tan square. 1 minus tan square by 1 plus tan square. And tan is 2 tan x by 1 plus tan. So remember those three formulas. Again, we came to the last three questions. I think we did exercise 3.3. I gave some homeworks also. 3.3, question number 22, we didn't do. We did 23 and 24. Now 22 and 25. Question number 22 and 25 are left. First, we will do then we'll come back to is this one who entered just now. I see if we start with question number 25. The question is to prove that cos 6x is equal to 32 cos raised to 6x. 32 cos raised to 6x minus 48 cos raised to 4x minus 48 cos raised to 4x plus 18 cos square x minus 1. 18 cos square x minus 1. See, in all these questions, even the previous questions also we have seen, one of the previous question also we have seen tan 4x, then cos 4x, etc. So here the bigger angle, 2x, 4x, 6x, 8x, that means even power, even multiples. The bigger angles can be broken into small pieces, we can say. 4x can be broken as 2x. Then that 2x can be again split into x. See that we need the answer in terms of x only. Cos x. Cos raised to 6x means cos x the whole raised to 6. So our aim is to change the 6x. 6x is a multiple of an angle. These are multiple angles. We say that we call it as multiple angles. Sin x. X is an angle. Sin 2x is a multiple angle. Sin 3x, another multiple. Sin 4x, another multiple. So these multiple angles, we have to make it into our given angle. That means we are breaking. So to break this 6x, we need to break it in terms of x. Cos 6x, the function here is cos 6x. So cos 6x, we have to write it in terms of cos x. That's the question. We know that cos 2x and cos 3x formula we learned. So if it is in terms of cos 3x, we know how to break it in terms of cos x. Similarly, if it is in terms of cos 2x also, we know how to break it in terms of x. So the 6x, see that this cos 6x, we have two options. Cos 6x can be written as 2 into 3x, or cos 6x can be written as 3 into 2x. Now you have to think, out of these two options, seeing the question, this is what we need to prove. Seeing this one, out of these two options, which option do you prefer? Even if you are taking both the options, you will get the answer. But in one of the options, it will be easy. So of these two options, the first one or second one, which one do you prefer? Yes, some of you wrote it. The first one, cos 2 into 3x. Why is it 2 into 3x? Why not this one? This is better. This is not wrong, it is also correct, but this is better. Why is it better? Because if you are using formula for cos 2 theta in terms of theta, see, cos 2 theta, we have three formulas. Cos square minus sin square, 1 minus 2 sin square, 2 cos square minus 1. So if we use 2 cos square theta minus 1, see this minus 1. This minus 1 is here. This is a better choice. Not only that, 2 cos square theta, we have to square it. Whereas here, 3 into 2x. Cos 3x formula, what is cos 3x formula for? Cos cube x minus 3 cos x. Cos cube x means we have to write the power in terms of 3. Then you need to expand whole cube. A plus b the whole cube you have to expand. If you are writing in terms of 3x, a plus b the whole cube you have to expand. Whereas if you are writing in terms of 2x, only a plus b the whole square we need to expand. So the expansion of square, a plus b the whole square is better than a plus b the whole cube. These are the reasons behind it. Again, even if you prefer first one or second one, you will get the answer. It's a different thing, but second one will be 10. So taking LHS, this question also came in board paper, cos 2 into 3x. Now we know the formula for cos 2x. Cos 2x is we use 2 cos square x minus 1. Why I use capital X here? Instead of this capital X, instead of this x, what is our angle here? Our angle is 3x. So instead of that capital X, we replace 3x. So this will be 2 cos square. So it is 2 cos square instead of this capital X or minus P, if you're writing theta is better. 2 cos square, use theta. Instead of theta, cos 2 theta is 2 cos square theta minus 1. Instead of cos 2x, I wrote theta. Theta can be replaced with 3x. So 2 cos square, instead of theta, it is 3x minus 1. 2 cos square 3x minus 1. 2 cos square 3x means square of cos 3x. And what is the formula for cos 3x? Cos 3x is 4 cos cube x minus 3 cos x. So cos 3x is 4 cos cube x minus 3 cos x. So cos square 3x means square of this one. That is 4 cos cube x minus 3 cos x the whole square minus 1. 2 into a minus b the whole square. A minus b the whole square is a square minus 2ab plus b square. A square minus 2ab plus b square. So a square means square of 4 cos cube x. Square of 4 is 16. Square of cos cube. Cos cube the whole square is cos raised to 6x. A cube, remember? A cube the whole square will be a raised to 6. So cos cube the whole square is cos raised to 6 minus 2ab. 2ab will be, first we multiply numbers. 2 into 4, 8. 8 into 3, 24. Cos cube into cos is cos raised to 4x plus b square. B square is 3 cos x the whole square. Square of 3 is 9. Square of cos x is cos square x. This minus 1 as it is. It's nothing. First we wrote 2 times this one. Then we use the formula for cos 2 theta. Then cos 3x. We use the formula for cos 3x. Then a minus b the whole square. Now open this bracket. 16 2s are 32 cos raised to 6x minus 24 2s are 48 cos raised to 4x plus 9 2s are 18 cos square x, and that is RHS is equal to RHS. Is equal to RHS. That's the answer. Now we skip one question. It is one doubt. It is multiple of those 3 numbers. Multiple of 3 numbers. I didn't get your doubt. No doubt. Okay. In the first step, you forgot to close the bracket. Yes. Here I forgot to. Yes, correct. Correct. I forgot to close the bracket. Then what is the other doubt? Other doubt. Okay, no doubt. Now we skip one question. That is question number 22. Prove that. Question number 22. Question number 22 is prove that cot x cot 2x cot x cot 2x minus cot 2x cot 3x minus cot 2x cot 3x minus cot 3x cot x minus cot 3x cot x is equal to 1. Is equal to 1. Now, see, this year, again, they are coming now already, otherwise. Say to my okay, I'm letting him. Yes. Now, see this question. Say to me, I kept you in waiting room for a long time, thinking that you will change the format of your name. I repeatedly said for the last 2-3 days, I am asking you to change the first write roll number, put a dot, then your name, then class. Repeatedly I am saying, and today, yesterday and last 2-3 classes, we are wasting nearly 15 minutes for this purpose. Still, you never change. So half an hour you kept in waiting room, still you didn't change, then I get you in. Next class onwards, I will never let anyone in if you are not in this format. I don't know what is wrong with you people. I don't know why you cannot understand. I have written the form. Today also I wrote the format with my name. 25. Put a dot. Your short name. Again, if you are writing a long name, then the last part, your class will not be displayed. I said it several times. You are not small kids of primary or KG or secondary. You are senior secondary students. In college, back in India, you are college students. Who cares? This question. See, there are few questions in most of the chapters. Generally, we have a basic method. When we get a question, we follow some basic rules and simplification. Whereas in few questions, if we follow the basic procedure, to get the answer will not be easy. You may get the answer, but it takes time. It won't be easy. See, for proving an identity in trigonometry, the method what we followed till now, we take LHS, keep on simplifying it, we get RHS as the answer. Another method, take RHS, keep on simplifying it, get LHS as the answer. Again, take LHS, simplify it, you will reach an answer which cannot be further simplified. Take RHS and again simplify it. If the simplified answers are same, still it is true. One more method is possible, transferring few terms to left hand side and right hand side, rearrange it and frame another question. For example, if your aim is to prove a minus b is equal to c minus b, to prove a minus b is equal to c minus b, instead of doing a minus b, transfer this. First we prove a plus b. Prove that a plus b is equal to c plus b. Once if you prove a plus b is c plus b, then we can come back to that. Therefore, a minus b is c minus b we can write. That means we start with another question. Prove that question. If that is correct, then transferring it is we go. So, and this one is very typical. You have to remember such questions. It is better in an A4 size paper, not this question, because even if you are highlighting these questions in your textbook, at the last moment, because your textbook, you know, is a very small textbook, right? So even if you are highlighting these questions in your exercise, in the last moment, just before examination, seeing all those pages, sometimes it may be overlooked. We cannot make it out because a lot of questions are there. Such typical questions where we deviate from our basic rules. Such questions, it is better to make a separate note in an A4 size paper. Take an A4. When I was a student, I used to do it. I was a student in an A4 size paper. I used to forward in A4 size paper. Then I write the question. Only question number, one question number. Then write that hints behind that page. The hints behind it. Write the fold it, write the question here. Don't write the solution, write only the hints for that question behind. And once in a while, so from every chapter, every exercise, we may get 3-4 questions. So at the end of the year, you may get some 25. This year, at the end of the year, some 20, maximum 20 questions, 20, maximum 20, 25 questions. That's all. Next year, more than 60, 70 questions. Anyway, so the advantage is once in a while, see these questions. If you are seeing these questions, if you cannot recollect the method, just turn the page and see the hint. After the hint, still, if you cannot remember it, take the notebook and learn it. Remember it. If you are seeing these questions once in a while, even once in a month, at the end of the year before examination, all these typical questions will be in your memory. So the advantage is even if you are getting this question or a similar question, at once you will remember, okay, this resembles with that question, that typical question. You can solve it very easily. So this is one of those questions. Same question, you can see worked out example 14 in your page number 71. You have a worked out example 14. This worked out example 14 is also exactly same as this question. So this example worked out example 14 and this question is exactly same. Remember these two questions. Remember these questions. Again, those who one of you asked a doubt. In this year, yes, if this is the first step, yes. This year, not only this one, this is not only the typical one. In sets miscellaneous questions. Example 14. I said example 14. In sets also miscellaneous exercise, we had some questions. A intersection B is equal to A intersection C, A union B is equal to A union C, prove that B is equal to C. Those questions are also typical one. Remember it. Few questions which we use some special technique. Take it. See this one. So here, what we do is we start with cos 3x. See, cos 3x. The formula for cos 3x. This cos 3x, we can write it as cos 2x plus x. Cos 3x is cos 2x plus x. Then we use cos x plus y formula. Remember formula for cos x plus y. Cot x plus y is cot x cot y, cot x cot y minus 1 by cot y plus cot x. Cot x plus y is cot x cot y minus 1 by cot y plus cot x. Again, remembering cot x plus y is also easy. Anyway, sin x plus y, cos x plus y, tan x plus y. These three are the first three formulas. That three formulas, anyway, you have to remember it. By making use of these three formulas, many formulas can be derived. Taking sin x plus y, we discussed it, that product formula, sin x plus sin y. Similarly, tan x plus y. You have to remember tan x plus y. Tan x plus y is tan x plus tan y by 1 minus tan x tan. This is the formula for tan x plus y. If you are remembering tan x plus y, cot x plus y can be remembered. What should do? Reciprocal and reverse it. Right? Reciprocal, reverse. Reciprocal, reverse it means this comes reverse. Cot x, cot y minus. This also reverse. Tan y, same. So write reciprocal and reverse it. That is the formula for cot x plus y. So these are. So remember those techniques. So cot 2x plus x. Now we can use this formula cot x plus y. Instead of x, we have 2x. Instead of y, we have x. So cot x cot y will become cot 2x. So left hand side is cot 3x. Cot 2x into cot x, because cot x cot y. Instead of x, we have 2x. instead of by x, minus 1 by cot y plus cot x becomes cot x plus cot 2x. Now cross multiply. Cross multiply cot x or cot 3x. Cot 3x multiplied with cot x plus cot 2x is equal to cot 2x cot x minus 1. Opening bracket, write the same order. Cot 3x cot x. Cot 3x cot x plus cot 3x cot 2x. That will become cot 2x. So I am writing it as cot 2x cot 3x or any order. If you write A into B or B into A, it is same thing. Cot 2x cot 3x. We open the bracket. Is equal to cot 2x. Okay, cot 2x cot x. I am writing it as cot x cot 2x. So that same order of question. Minus 1. Now see the question. Now what you take this minus 1 to left hand side. 1 is equal to cot x cot 2x. Take these two terms to right hand side. Minus cot 2x cot 3x minus cot 3x cot x. 1 is equal to, that is, we got A is equal to B. Now write in reverse order. That is cot x cot 2x minus cot 2x cot 3x minus cot 3x cot x is equal to 1 group. We got the answer directly. So see that this question, this is typical reason. Here we didn't go for taking one side, simplified it and get the other one. We don't have to solve this. No, this is what I said. We don't. If you are solving LHS, cot x, cot x, if you are finding formula for cot x, again cot x, cot x, again cot. If you substitute, then lot of fractions, taking LCM simplification, it takes lot of time. It will take some pages. So this is a better choice. That is what I said. Few questions in which we deviate from our basic techniques. You have to remember it. So this is the technique. We started with the expansion of cot 3x using formula cot x plus y. Then directly cross multiply, we got the answer. This is, so our exercise is over. Now, tomorrow we can extra class at 2 o'clock, and tomorrow evening 5 o'clock we discuss it. We have a test. I hope you have completed. How LHS is, you can see this. We got LHS and RHS of the question. We got LHS and RHS of the question. This is what to prove. Now we come to the next topic. That is trigonometric equations. So trigonometric test everything we discussed in the group. Check the group. Let me take the attendance first. Yes. Now, about test and everything we discussed in the group. What is the other doubt? So can you explain this question once more? See this, that's all. Taking what we started with this cot 3x. We break this cot 3x plus x and use the formula cot x plus y. Using formula cot x plus y, cross multiply, we got the question answer. That's it. Now, next one, trigonometric equations. See, trigonometric equations. Solving equation. You know what an equation is. You learn linear equations, quadratic equations. Similarly, trigonometric equations means equations involving trigonometric functions. Solving an equation is finding the value of the unknown. Quadratic equation, value of x. Similarly, if any equation involving trigonometry, sin x, cos x, tan x, etc., finding the value of x, that is called its solution. Or solving the equation means finding the value of x if x is the angle in the given. If it is theta, the value of theta. See that last year, when we learned trigonometric ratios, if you are writing sin x is equal to 1 by 2. This is an equation. It's a trigonometric equation. It is not the new lesson. It is a continuation only. Someone else is a new lesson. No. Trigonometric equation. Next exercise. We are going to next exercise. Sin x is equal to 1 by 2. Now, solution. This is an equation. Solution of an equation means the value of the variable which makes it a true sentence. That is a solution. You know it. For example, x plus 3 is equal to 5. The solution. Here the solution is x is equal to 2. Why 2 is called a solution? Because if x is 2, LHS and RHS become same. So solution means the value of the variable which makes it a true sentence. So sin x equals 1 by 2. Then what value of x will make this true? We know that last you learned sin 30 degrees is 1 by 2. That means the value of x is 30 degrees. This is what you learned last year. Value of x is 30 degrees. So sin 30 gives 1 by 2. Do we have any other value of this x, or do we have any other angle which gives its sine as 1 by 2? Yes, we have. Which one? Sine 150. See, sine 150. Sine 150 degrees will be sine 180 minus 30. 180 plus or minus, even multiple. Function remains same. 90 plus or minus, 270 plus or minus. What multiples of 90? Function changes to co-function. Even multiples of 90. 180 plus or minus, 360 plus or minus. This all gives the function is same. Then the sign we have to check whether it is positive or negative depending on the quadrant. So 180 minus theta is sin theta will sin 30. That's also 1 by 2. See that? Not with that. Not with this value. We know sin 30. This is 30 degrees. This gives 1 by 2. We learned it. The terminal rate. An angle is formed when a ray is what? 30. Again, if it keeps on moving, moves and moves, it becomes 360. Again, 30, 390. To find 390, sin 390, the position of the terminal ray is same as the 30 degrees. I hope you got the idea. The 30 degrees, sin 30, the position of the terminal ray is this one. Even if you take plus 360 degrees, 390, again the position is same. That means after each revolution of this terminal ray, the position of the terminal ray remains the same. At all these points, the value of sine will be 1 by 2. That means sin 30 is 1 by 2. Even if it is sin 390, if you are adding 360, sin 390 is sin 360 plus 30. Again, 360 is an even multiple of 90. 90 into 4. For even multiple of 90, function remains same. So it is sine 30 only. Again, 360 is here. Plus means in quadrant 1. Positive, sine 30. Again, the value of sine 30 is 1 by 2. That means, if you are writing sine x is equal to 1 by 2, what is the measure of the angle? If someone is asking which angle value gives sine of that angle is 1 by 2. Sine 30 gives 1 by 2. Even sine 390 also gives 1 by 2 because 360 plus theta. Even 720 plus 750. Sine 750. Sine 750 is sine 720 plus 5. 720. Even multiple of 90. 98 times. 9 8s are 72. 98 times. Again, even multiple function remains same. Sine 30. Again, sine 30. 720 means this terminal ray, it took 2 times. It took 2 rounds. First round, 360. Again, second round. That means the sine value keeps on repeating after 360 degrees. After every 360 degrees, we get the same value. Is it? It keeps on repeating after 360. Similarly, for cos also, after 360 degrees, it keeps on repeating. Whereas for tan, after 180, it keeps on repeating. After 180, it keeps on repeating. Reason, see tan 45. Tan 45 is 1. Tan 45 is 1. Again, if you take here, this is 180 plus 45. See, this is 180. 180 plus 45. That's also tan 45. In quadrant is positive. This is also 1. So remember, sine and cos repeats after a period of 360 degrees. 360 degrees, or we said 2 pi radian. 2 pi. Sine and cos repeats after 2 pi, and tan repeats after pi, after 180 degrees. Tan repeats. So for the equation, sin x is equal to some value, we have infinitely many values of x, because after every 360 degrees we get the same value. 30, 1 by 2, again after 1 by 2, again 1 by 2, again 1 by 2, 5. So we have infinitely many values. These infinitely many values, these infinite values, these are called general solution. So in general solution of a trigonometric equation, we have infinitely many values. And I hope you got the idea of why do we get infinitely many values? Because after every 360 degrees, this terminal ray keeps on rotating, it gives the same value. General solution. Again, the first two solutions which comes in the first round. First round means the first 4 quadrants. First 4 quadrants. The solution which comes between 0 and 360. They are called principal solution. Principal solution. So principal solution and general solution. The difference between principal solution and general solution, we know that for a trigonometric equation, we have infinitely many solutions. Among this infinitely many solutions, the first 2 solutions which comes within 360 degrees, within the first 4 quadrants, they are the principal solution. And see that for all trigonometric functions, we see only sine, cos, and tan. If it is sine, cos, and tan, the remaining 3 are reciprocals. For all the trigonometric functions, there are 2 principal solutions. For example, if you are getting positive, sin x is 1 by 2 means positive. If sin x is positive, we know that we get positive value in quadrant 1, also one positive value in quadrant 2. That means you will get 2 values, one in quadrant 1, one in quadrant 2. If it is cos, again we get 2 positive values for cos, one in quadrant 1 and second one in quadrant 4. In quadrant 4, cos is positive. In the case of tan, we get positive values in quadrant 1 and quadrant 3. Tan is positive in quadrant 3. So if we get positive values, we get positive values in 2 quadrants. Same is for negative value. Negative value also we get 2 quadrants. In all, we have only 4 quadrants. In all 4 quadrants, out of these 4 quadrants, in 2 quadrants, the function will be positive, and in 2 quadrants, the function will be negative. You can observe it. For example, sine. Sine is positive in quadrant 1 and 2, whereas sine is negative in quadrant 3 and 4. In the case of cos, cos is positive in quadrant 1 and 4. Cos is, I'll come to it. Majid, I'll come to it. Cos is positive in quadrant 1 and 4. Cos is negative in quadrant 2 and 3. In the case of tan, tan is positive in quadrant 1 and 3. Tan is negative in quadrant 2 and 4. So we have 2 positive values and 2 negative values within the first 4 quadrants, which are the principal solutions. Then again, if it keeps on rotating for higher values, again that repeats. As I said, quadrant this one, plus 360, again comes the same position. They are general. After the first revolution of the terminal rate, after the first revolution of the terminal rate, that means after 360 degrees, the remaining angles all are general solutions. They are general solutions. The first 2 is you asked me a doubt. That means sin x is equal to 1 by 2 has not only 1 by 2. For everything we have. What is general? General solution means we have infinitely many solutions. Why? Because sin 30, sin x is equal to 1 by 2. What is the value of x? X is not only 30. 30, one value, one full revolution, 390. Again same, one more revolution. So how many times this revolution we can take infinitely many times. It goes on. Is it? It goes on. So if y is equal to sin x, or we take even from the graph, y is equal to sin x. Except the resolutions. See, we know that the graph of sine function, it goes in this way. We discussed yesterday. Is it? What we said is this y value. See, sin x is equal to 1 by 2. If sin x is 1 by 2, that means sin x. The value, but this is y. Y is equal to sin x. Which value of sin x is 1 by 2? See, this is 1. You can see this value of x is 1 by 2. Even here, or even sin x is equal to 1. This is better, more easy. Sin x is 1. If sin x is 1, which all x values will give value of 1? See here, this is 1. This is 1. At this point, we get 1. This is 5 by 3. Again, at this point, again we are getting 1. This is 360. Because this is 90, 180, 90, this is 180, this is 270, this is 360, then this is 450, is it? 90, again see, 450 degrees. 90 plus 360, 90 plus 360 is 450 degrees. At 450 degrees also we get 1. Again, if you are adding another 360 degrees, if you are adding another 360 degrees, it comes here. Here also we get value 1. So at this point, this point, this point. So similarly, how many points we can take? It goes on to infinity. Infinitely many values are there. X. For infinitely many values of x, the sign value, the value of function, so y will be 1. Because wherever this graph touches 1. Similarly, wherever it touches 1 by 2, you can see lot of bases are there. That is why these are general solutions. Anyway, so this is the general solution and principal solution. So principal solution means it comes in the first 4 quadrants. That means from 0 to 360. So write those things. Just write it, will stop. Trigonometric equations. Trigonometric equations. Tomorrow, 2 o'clock, we have extra class and we'll be completing this an important topic. Trigonometric equations. Right, equations involving, you have mock test of English, not at 12, it is at 12:30. Right, equations involving trigonometric functions. Equations involving trigonometric functions are trigonometric equations. Equations involving trigonometric functions are trigonometric equations. The value of sin x and cos x. The value of sin x and cos x. The value of sin x and cos x repeat after an interval of 2 pi in bracket 360 degrees. That is what we discussed. The terminal rate, first quadrant, again it goes, we get the same answer. Sin x and cos x repeats after an interval of 2 pi. And tan x repeats after an interval pi of 180 degrees. Therefore, we have infinite solutions. We have infinite solutions for a trigonometric equation. So we have infinite solutions for a trigonometric equation. We have infinite solution for trigonometric equation. Abdul Bandi, your query, I became self-sufficient. Your query, I became self-sufficient. Yes. After, therefore, there are infinitely many solutions. These solutions are called general solutions. These solutions are called general solutions. Next slide. The first two solutions. The first two solutions are considered as, or the first two solutions, that is 0 less than or equal to x less than 2 pi. That is 0 less than or equal to x less than 2 pi, because 0 less than x less than 2 pi are principal solutions. Principal solutions. Okay, that's it. So this is the general solution and principal solution. So tomorrow at 2 o'clock, any doubt? Anything else? We have mock test. Not. Your English test is 12:30 only, not at 12 o'clock. Any doubts? So solution. The last time, the first two solutions, that is 0 less than or equal to x less than 2 pi, is the principal solution. It is a principal solution. Yes, you can go for English test. It is 12. Yes. Anything else? So I'll meet you tomorrow at 2 o'clock. Right? Then we don't have enough, but we don't have enough time to practice trigonometry. Trigonometry only basic question. Trigonometry only the formulas. No trouble. What do you learn? Till last class I said. Test will be 10 questions. Tomorrow's test will be 10 questions, 1 mark each. All MCQ. And then the amount of English. Anything else? Okay. Then what is the other doubt? Someone asked me again. Okay, thank you. Yes, Abdul Bakir wanted to ask about my hairstyle. I became self-sufficient. I came to experiments in my hair only, right? Not in someone else's hair. Okay, see you tomorrow at 2 o'clock.